Okay. Hope everyone's doing all right. Right, I'm out with the swim team at our state swim meet. But I recorded this, right? And so I guess for this class period, right, you guys are welcome to work with your classmates on homework 4.5. You'll need to use your graphing calculator for that. It says so in the directions on Big Ideas. If you don't have one, right, I emailed everybody a link, so you should be able to use an online version. This is an app. Yours is in the browser, though. So you should use something like this. And again, the process, right, is you'll go to this button here, stat, and then in edit, you're going to type in all these numbers in your list. And this is my X values. These are my Y values. And then we'll go over to here. The calc menu, number 4 is my linear regression. And this will give me like my y equals mx plus b. And this r is the correlation coefficient. If it's close to 1, or 1's its maximum value, we'd say that's pretty strong positive correlation. If it's close to -1, we say that's pretty strong negative correlation. So again, this is for the homework. That's like maybe what you should do at the beginning of class. Be sure you hit submit, or else it'll go into the gradebook as late. The rest of the class period, though, is going to be about this. This is the last section in chapter 4. It's about arithmetic sequences. And really, this is like another way about talking about linear equations. This is like a good NWA style question, right? The ACT also does stuff with this. This will basically just recognizing patterns. And so here, right, maybe you can guess this. We're doing arithmetic sequences. We say that a sequence is an ordered list of numbers, and that each number in the sequence is called a term, right? Maybe you've noticed with chapter 4, we've kind of got a lot of vocab going on here. We'll do a bit of review next week. Our quiz will be next Thursday and Friday. So Thursday, that is what we'll have our gold day quiz. Friday will be whenever we have our purple day quiz. So here is an example of a sequence. And maybe you'll notice the pattern already, right? That's what this is all about. I've got 5, and then 10 and 15 and 20 and blah, blah, blah. You probably see the pattern here, right? Some vocab first before we talk about this. We use this a sub n. N is any number in my sequence. N is the nth position. All right, what do we mean by that? The first term in my sequence, a sub 1, is the number that happens first. So that's just 5. In the same way, the third term in my sequence, maybe you could figure this out, that'd be this a sub 3. That's in the third position. And I could do this for any number n, right? So I could make this, what is the 100th term in the sequence? I could figure that out. The subscript, that n, tells us where to look for the term in the sequence. Now, this particular one, again, I'm saying this is like about a pattern recognition thing. This sequence is called an arithmetic sequence. Or maybe you've, familiar with the word arithmetic. That's basically just adding things together, which is exactly what we're doing here. What number are we adding? That's the common difference. Here, I'm adding 5. I'm doing plus 5 to all these things. And this is how much one term differs from another. I do plus 5 to here, plus 5 there, plus 5 there. Right, so one style of question would be to write the next 3 terms in this arithmetic sequence. -7, -14, -21, -28. Right, you could probably see here the next 3 terms are then going to be -35, -42, and -49, because the common difference is -7. I'm doing -7 from each of these things here. We can identify sequences not just from a list of numbers like what we did right here, but from a graph. Usually the x-axis tells us n, the position in the sequence of a certain number, and then the y-axis is going to tell us a sub n, which is the value of that term. All right, so here is an example. I'm given this arithmetic sequence, and I can write it here. I forgot to type it in there. That's okay. Arithmetic sequence 8. 4, 8, 12, 16. This is an arithmetic sequence, blah, blah, blah. How can you tell? It's got a common difference of 4. So again, the x values, these will be the position. So what position do you have in your sequence? I would say the number in the first position, the term that goes with this, is going to be 4. It's the first term. The second term is 8. The third term is 12. The fourth term is 16. And I could graph all these. So 1 comma 4, there's my first term. My second term is 8. My third term is 12. And then my fourth term is 16. All right, what do you notice? This should be obvious. This is what our chapter is all about, right? It's linear. And we'll connect that on our next page. It's linear. An arithmetic sequence's graph is linear. It makes a line. Maybe I could even give this an exclamation point. It's exciting. Here in this one, does the graph represent an arithmetic sequence? Okay, looks like a line. Maybe it would pay if I checked, right? So these are the numbers of my sequence, 15, because that's the first number. The second number is 12. The third number is 9. And then the fourth number is this 6 right here. And we could go on forever, right? Maybe you can notice what is the common difference between these? How much am I changing as I go? -3 for all of these. So, right, we would say this is an arithmetic sequence because there is a common difference of 3. And I could represent the common difference like this. I could say D is -3. Maybe just in words I could write that out. Common difference. That's okay. So again, this is recognizing patterns. This first part, not too bad. This second part, this last page here, this is where things get a little weird. As we saw in the last two examples, we can express an arithmetic sequence as a linear equation. And this will maybe be the hard part, right? I'm not as concerned with you guys getting this. Your homework 4.6 will have only a couple examples like this one. I'm really more interested in, can you recognize these things like we had up here? So to make an equation, we will say that I can find the nth term of a sequence, an arithmetic sequence, by taking the first term and then adding the common difference multiplied this whole n minus 1 thing here. So here's how this works, right? So I'm just going to go ahead and consider a new made up sequence, new one. We'll say the first position, I got the first term then is a sub 1. And using a sub 1 in the common difference, I would say that this is just going to be 1, right? So here I've got 4. Right, the first term, I'm not adding anything to it. That's why it's just straight up like that. The number in the second position, right? So this is the second number in my sequence. That's a sub 2 using a1. So I'm not going to use this a sub 2. I'm going to say that this is the same thing as taking what I had first, and I will be adding the common difference. And maybe you could look at these numbers up here, right? This is the sequence that I'm talking about. To get to 7, I had to do 4 plus 3. So my common difference here is 3. Okay, that makes sense. Right, my next term, maybe you could start figuring out the pattern here. My third term is this a sub 3. And I'm going to say that this is the same thing as doing the first term, a sub 1, 4. And I've got to add 3 twice. I've got to add 2d. So this is 4 plus 2 times 3, because I added 3 twice, and I would get 10, right? I added 6, and I got 10 here. I could do this forever, for as long as I want, right? That's what these little dots mean here. But ultimately, I'm going to go up to the nth term. So this is the nth term in the sequence here, a sub n. And I'll say that's a sub 1. Notice here, I did d times 1, and I did d times 2 here, which is 1 less than the position that I have. And again, I'm not super concerned about you guys being able to reconstruct this every time. That's a minus 1 times d. Right, so then my last term will be 4 plus n minus 1 times 3. Okay, now let's do an example. This will maybe be better, right? Again, I'm not super concerned about you guys constructing this. This is just the proof. This is where this equation comes from. I'm not going to ask you to prove this. You guys could probably get here, no problem at all. We're going to write an equation for the nth term of the arithmetic sequence, 14, 11, 8, and 5, and then we're going to find the 50th term. So, right, maybe the first thing to do would be, what is my common difference? Right, you guys are probably shouting at the video right now. It's -3, right? I do 14 minus 3, 11 minus 3, 8 minus 3, and so on and so forth. What is the first term then? What is this a sub 1? That's going to be 14. It's the very first term that I have. So then using this kind of standard thing here, my formula, I will say that I can find the a sub nth term, the nth term in the sequence, by doing my first term plus n minus 1 times my common difference. Right, that's the formula that we had above. I'm not doing anything new there. But now I know what these things are. I know that the first term is 14. I know that the common difference is 3. Or excuse me, it is negative 3. And I can actually distribute this into this thing here. So I get a sub n is equal to 14 minus 3n plus 3. Okay, cool. Maybe I'll continue this up over here. So then a sub n is equal to 17 minus 3. And I could actually, look at this, rework that as if it were in y equals mx plus b form. So this will say to figure out what your nth term is, maybe I can even draw this away here. Figure out what your nth term is, multiply the n by negative 3 and add 17. So if I'm trying to find the 50th term, I'm going to be doing negative 3 times 50 plus 17. And I've got this written down next to me, so no need to worry about this. This is going to be negative 30 or 131. 133. Jeez, I said it wrong twice. That's the 50th term. We could do a similar thing here, right? We need our pieces. We need what is the common difference here? Looks like plus 1. What is the first term here? Looks like 4. Okay, time to find my arithmetic sequence. I've got now 4, my first term, plus n minus 1. This is in every arithmetic sequence. Again, I'll give you the definition if I quiz you guys on this, and I'm thinking that I will. I'm going to give you the formula, this one right up here. You've just got to be able to identify what is the difference, what's the first term, and then plug these things in. So I distribute that 1 into all these things. I get 4 plus n minus 1. So then my sequence here, I could say is not 5, but 3, because I've got 4 minus 1, 3 plus n. Writing that in y equals mx plus b, I can find that a sub n is n plus 3, right where my slope is like 1 here. So then again, I'll make myself some room. I'm saying, what's the 25th term? Where's this a25 coming from? Right here. That's the direction. That's what I'm asking for. Gives me 25 plus 3, and 28 is the answer. And that is it for arithmetic sequences. We'll probably have some time on Monday to review this homework before we do more review. We'll be reviewing chapter 4 on Monday and on Tuesday. And if you've got purple days, we'll be reviewing again on Wednesday. If you've got any questions, feel free to reach out, right? I am available. I'm thinking maybe the 4.5 homework will be more challenging. But I hope you guys have a good weekend, and I'll see you later.